Well, hi everybody. You found our first lesson for intermediate algebra. The first thing we need to do for this course is become familiar with the 7 fundamental properties of exponents. We use those all the time, and we're going to use them right away in this course. So in this lesson, we have 2 main goals. First of all, I want you to recognize what the 7 properties of exponents are and why they're true. We'll look at each of those. And then we're going to use properties to simplify algebraic expressions. That's going to allow us to add, subtract, multiply, and divide polynomials in our next few lessons. It's going to allow us to do factoring. It's going to allow us to do lots of other things over the next few months. So let's get started. Okay, there are 7 important properties of exponents that you're going to need to be familiar with. We're going to work through them one at a time, and then we'll provide a summary of all of them at the end. So the first one, suppose we wanted to multiply 10 to the 4th power by 10 to the 3rd power. If you think about that, that's really the same as saying 10 times 10 times 10 times 10, that's 10 to the 4th, times 10 times 10 times 10, that's 10 to the 3rd. If you do that, we've really got 10 multiplied by itself 7 times here, and so we could say that that is 10 to the 7th power. And at that point, you could probably draw a conclusion. If you have the same base with different exponents and they get multiplied together, 10 to the 4th times 10 to the 3rd, that gives us 10 to the 7th. So that gives us 10 to the 7th. So in general, when we multiply powers of the same base, we can simply add those exponents together. X to the a times x to the b is x to the a plus b. That's our first property. So for the example that's shown here, we can say that n times n to the 4th times n to the negative 2nd, those are all the same bases, we can add the exponent. Be careful here, because what is the exponent on n? A lot of people will incorrectly say that that's 0 since there's nothing there, but that's the same as n to the 1st power. So we have 1 plus 4, which is 5, minus 2, that leaves us with n to the 3rd power, and we've simplified that expression. All right, our second property, suppose we wanted to divide 10 to the 8th by 10 to the 2nd power. Well, that's the same as 10 to the 8th over 10 to the 2nd power, which is the same as 10 times itself 8 times, divided by 10 times itself twice. Now, as you can see, a couple of these 10s are going to cancel off, and in fact, however many of them we had on the top will cancel off the ones on the bottom. In other words, in this case, we lose 2 of them. That's the same as 10 to the 6th. So you can probably generalize that. 10 to the 8th divided by 10 to the 2nd is 10 to the 6th. Our rule here is when we divide like bases with different exponents, we can simply subtract the exponents. X to the a over x to the b is equal to x to the a minus b. So let's look at the example that's shown here. We have a to the 4th over a. That's like saying a to the 1st, and so we could say that that's equivalent to a to the 4 minus 1. That's a to the 3rd power. And we have b to the negative 3rd over b to the 5th. Okay, even though the top is negative, we're still going to subtract off the bottom power. And negative 3 minus 5 leaves us with b to the negative 8th. So a to the 3rd, b to the negative 8th is our simplified expression. And we're going to see in a little bit that there's another way that we could write that as well. Okay, our third property of exponents says that if we have something like 10 to the 4th and we square that, that's the same as saying 10 to the 4th times 10 to the 4th. Or in other words, we have 2 groups of 10 to the 4ths. And we saw earlier that 10 to the 4th times 10 to the 4th, that's the same base. We could add those up. That gives us 10 to the 8th. So a power to a power, it tells us how many groups of each power we have. We have 2 groups of 4. That leaves us with 10 to the 8th. And so we can generalize that and say when a power is raised to another power, the exponents get multiplied. X to the a to the b is x to the ab. And we can generalize that and say x, y to the 3rd, z to the negative 2nd, all raised to the 4th power. We can multiply these exponents. We have x to the 1st to the 4th. We multiply 1 times 4. That gives us x to the 4th. Y to the 3rd to the fourth power. That means we have 4 groups of y to the third. Multiply those, and we have y to the 12th. And z to the negative second to the fourth power, we multiply that power to a power, and we get z to the negative 8th. And there it is. Now be careful, because that rule is often confused with our first property. But notice that our first property says we have the same base multiplied, but the exponents are different. And so we add those exponents. But in this property, we have a single base raised to a power with another power on top of it. And in that case, the exponents get multiplied. Okay, our third property deals with powers of products. So, for example, suppose we have 2 times 10, and we raise that to the third power. That's the same as saying 2 times 10 times 2 times 10 times 2 times 10. But the associative property of multiplication that we saw in our first lesson says we can associate these any way we want. We could put all the 2's together and all the 10's together and say that that is the same as 2 to the third times 10 to the third. Or in other words, if two things are multiplied together, then we can apply that exponent to each of the factors individually. And in fact, we used that property in our previous example to say that when things are multiplied, xy to the n power, the exponent applies to both. So negative 2x to the fourth y to the third, that's the same as saying negative 2 to the third power, x to the fourth to the third power, and y to the third power. Negative 2 to the third is negative 2 times negative 2 times negative 2, that's negative 8. X to the fourth to the third, as we saw just a minute ago, is that product. That's x to the 12th, and y to the third. Now be careful here, because this leads to another common mistake. Notice that these things inside the parentheses have to be multiplied together for that to be true. If we have two things that are added together and raised to a power, that is not the same as the sum of their individual exponents. That is to say, we can't apply the exponent if these are separate terms, only if they're multiplied together. If we had to simplify this expression, we would have to take x plus y and multiply or FOIL it out. So be careful of that difference. It's a natural extension of that to say that if we have two things that are divided inside parentheses, and that usually that looks like a fraction, then if we apply an exponent, the exponent applies to each of them individually. So x over y to the nth is the same as x to the nth or over y to the nth. Or when we apply a power to a fraction, we apply the exponent to both the top and the bottom. Notice here that the denominator can't be 0, but we can never have 0 in the bottom of a fraction, so that's not really going to cause us too much trouble. But let's look at this example. Negative 2a squared over b to the negative fourth. Well, that negative sign can easily be associated with the numerator or the denominator, but not both. Let's call it negative 2a squared over b to the negative fourth. Let's raise that to the third power. Okay, negative 2 raised to the third power, as we saw, is negative 8. A squared to the third power gives us a to the 6th. We're going to multiply those. And b to the negative fourth to the third power, that's b to the negative 12th. Now again, we could go a little bit further with that, as we're going to see in our next two properties, but for right now, we'll be satisfied with that. Okay, our next one, a zero exponent. What is 10 to the 0 equal to? Well, if you think about this for just a minute, let's look for a pattern. We know that 10 to the third is 10 times 10 times 10, or 1,000, one with 3 zeros. We know that 10 squared is 10 times 10, or 100, a 1 with 2 zeros. We know that 10 to the first power is just the same as 10. So then 10 to the 0th power, if we look at our pattern here, we're losing a factor of 10 or dividing by 10 in each case. If we lose another 0, our next number in this sequence has to be a 1. And so in fact, 10 to the 0th power has to be 1. And we can generalize that and say that any number raised to the 0th power is going to be 1, as long as that base is non-zero. We can't have 0 to the 0th power. That's a whole nother problem in mathematics, and we won't really have to deal with that. So a simple example of that if you're asked to simplify a to the third times b to the fourth times a to the negative third, well, we can combine the exponents on the a's. We have a to the third and a to the negative third, as we saw earlier. We could add those exponents together, and that gives us a to the 0 power, b to the fourth. But the a to the 0th power, that's just the same as 1b to the fourth. And so those a's basically cancel each other out, and that leaves us with just b to the fourth. The key here being that a to the 0th power can be replaced by a factor of 1. Now let's go back to our powers of 10 for a minute. We said that 10 to the third is 1,000, 10 to the second is 100, 10 to the first is 10, and 10 to the 0 is 1. Let's keep going in this pattern. The next power of 10 in our list would be negative 1. And if we divide 1 by 10 again, every time this number is getting smaller by 1 decimal place, that's going to be the same as 0.1, which is the same as 1/10. If we go another step, 10 to the negative 2, that's the same as 0.01, which is the same as 1 over 100, which is the same as 1 over 10 squared. And so in general, a negative exponent can really be just put in the denominator of the fraction to form equivalent expression. And so that leads us with our 7th property. Anything with a negative exponent on it can be written as the reciprocal of that value with a positive exponent. And in fact, a negative exponent pretty much always means reciprocal. So in this example, we have 3x to the negative third over 2 to the negative second, x to the fifth. Let's simplify this. Well, the 3 will stay right where it is. It has an exponent of 1. X to the negative third, we don't like negative exponents, so we'll move that down to the bottom of this fraction. And just as we have a negative exponent in the denominator, let's send that up to the top of our expression, so we have 2 squared. Moving those values with negative exponents to the other half of the fraction changes their sign. The x to the fifth was already positive. We don't want to mess with that, so we'll leave it right there. And so this becomes 3 times 2 times 2, or in other words, 12, over x to the third times x to the fifth. Are you going to multiply or add those exponents? You should add them, and that becomes x to the 8th. So we have 12 over x to the 8th. Now that means that we could also write that, though, if we wanted to bring this denominator up to the top, that's the same as 12x to the negative 8. Now those are both equivalent. The advantage of our first form was we had a positive exponent, and that's what we usually like. But the advantage of the other simplification here is that we had no fraction. So when you go to simplify, you'll always be asked to either simplify so that all exponents are positive, or you'll be asked to simplify so that we have no fractions in our answer. And there's always one possibility for each. Okay, so those are our 7 exponential properties. These would be handy for you to write down in your notes and to study. We'll be using these on a regular basis, especially in just a bit here when we start our work with numbers in scientific notation. When we multiply like bases, we add the exponents. When we divide like bases, we subtract the exponents. When we have a power to a power, we multiply the exponents. If we have a product raised to a common power, we can apply the power individually to the factors. A fraction raised to a power, both the top and bottom get that power applied. Anything to the 0 power except 0 is 1, and a negative exponent can be rewritten as a reciprocal with a positive exponent. Okay, let's simplify our example here. Before we go any further, I want to note that there's more than one way to simplify these, and though we should always end up with the same result, the individual steps that you choose can vary a lot from what I'm going to do. So what I'm going to show you isn't the only right way, but it's probably about the shortest possible way. Okay, so let's start in our numerator. We have a bunch of things multiplied together, all with an exponent of -1. That means that we can apply those individually, and this becomes 3 to the -1, x to the -3 raised to the -1 power. Those get multiplied together to become x to the third. The y will get an exponent of -1. And the z will have 2 times -1 for an exponent, which is going to be -2nd power. Let's do the same thing in our denominator. Power to a power gets multiplied, so z to the -2nd to the 3rd, that gives us z to the -6th. X to the 5th to the 3rd, that's x to the 5 times 3, or 15. Okay, now we don't have any parentheses left. Now, any of the negative exponents we'll make positive by moving them to the other half of the fraction. So 3 to the -1, we're going to drop that down to the denominator and make it 3 to the +1, which we'll simplify in a minute. That x to the 3rd can stay on top. Y to the -1, we'll send that down and make it y to the +1. Z to the -2nd, we'll send that down and it becomes z to the +2nd. Now this z to the -6th in the denominator, we'll move that up to the top to become z to the +6th, and x to the 15th we can leave right in the denominator since it's already positive. So we eliminated parentheses, and now we've made all the exponents positive. That was, after all, our instruction here is to use positive exponents. Now let's simplify this even more. Our 3 is in the bottom, and we don't need to say 3 to the 1st, we can just say 3. We have 3 x's on the top, that is to say x times x times x, but we have 15 of them in the bottom. So the 3 that are on the top cancel with those that are in the bottom, and we're left with x to the 12th power in the denominator. That y, the only y, is in the denominator, y to the 1st power, but we don't need the 1. And we have z to the 6th over z squared. 6 minus 2 is the same as canceling 2 of those, and we're left with z to the 4th. And so this simplifies with positive exponents to be z to the 4th over 3x to the 12th y. Okay, there's a practice problem on your screen. Why don't you take a minute and see if you can simplify that so that you're left with only positive exponents. Unpause when you're ready to see that solution. Okay, let's take a look. First of all, this negative sign could be put in the numerator or the denominator, but in either case, once it gets squared, it'll be a negative times a negative, and that's going to become positive. So the negative sign will square off and disappear. We have a to the 9th to the 2nd power, that's a to the 18th. We have b to the 0 power, that's the same as a 1. We have a to the -5th squared. So we're going to have power to a power. Let's multiply those and put a to the -10th. It's very tempting to say that that's a to the 25th power, but a power to a power, you multiply those exponents. And that's all over a to the 2nd power. So now we're left with a to the 18th times a to the -10. We can combine those. 18 minus 10 leaves us with just a to the 8th, or 1a to the 8th if you prefer, over a squared. And we have 8 factors of a on the top, but only 2 on the bottom. Those will cancel. In other words, we can subtract, and we are left with a to the 6th. Now you might say, well, wait a minute, those are in parentheses. We should have simplified inside that parentheses first. It's true, you could do that, and you're going to get the same result. So if you did that, that's just fine. Now here again, we simplified this so that when we were done, we had positive exponents in our expression. Let's do one so that we simplify and are left without any fractions. We'll do this one together. All right, well, let's do just that this time. This time, let's do the work inside these parentheses before we apply that exponent of -3. So if we start simplifying inside the parentheses, in our numerator, we'll have 4 p squared squared, that's going to be p to the 4th, and q squared. And in our denominator, we'll have 2p to the -6th q. Now, 4 over 2, of course, reduces for its own sake. And so 4 over 2 is the same as 2 over 1. The p to the 4th will stay. Q squared over q, well, that's just going to leave a q in the top. And if we bring that p to the -6th up to the top, it becomes p to the +6th. So the only thing that's left in our denominator is that 1. This is still all going to be raised to the third power. I want to emphasize that the reason that that q is alone on top is because one of the q's on the top canceled with the q on the bottom, leaving just one q on the top. Okay, well, let's go a little bit further here. So that's really the same as saying 2 p to the fourth and p to the sixth. That gives us p to the 10th and 1 factor of q, and that's all going to be raised to the negative third power. Now, since this whole thing is to the negative third power, we can take the reciprocal of the whole thing and say that it's 1 over 2p to the 10th q, but since we've sent it to the denominator, it's now to the positive third power. Now, if we take that a step further, this is the same as 1 over 2 to the third power is 8. P to the 10th to the third power is p to the 30th, and q to the third power is, of course, q to the third. So we've simplified this, but we have positive exponents. Our instructions were to express this without fractions. So how do we get rid of this fraction? How do we get rid of everything down below here? Well, we're going to send it back up to the numerator, and we'll put a negative exponent on everything. So 8 will go up to the top. Remember, this is 8 to the first, so this will become 8 to the negative 1. P to the 30th will go up, and that becomes p to the negative 30th. Q to the third will go up, and that becomes q to the negative third. And now we don't have any fractions, so we have to accept the negative exponents, but we did simplify it without fractions. Now you might note that we could have done that a step ago. We could have said, before we even introduced a fraction, 2 to the negative third power, that's 1 over 8, or 8 to the negative 1. P to the 10 times negative 3 is p to the negative 30th, and q to the negative third. In any case, our simplification has to be the same. Okay, well, that wraps up our first short topic on the properties of exponents. In summary, you need to be familiar with these 7 properties and be able to apply them, and you'll be able to do that in your first WebAssign assignment here shortly. We're going to use these in our next short topic to see how we can add, subtract, multiply, and divide numbers that are in scientific notation using these properties. So we'll see you in the next lesson.